This is the solution set to problem number 23 in the Halliday chapter 5. The givens that are, for lack of a better word, given to us are the acceleration, which equals 0.5 meters per second squared, along with mass 1 equaling a value x, which was m in the problem, but I changed to x. And the units is kilograms, and M2 is 2x, and M3 is also 2x kilograms as well. For our free body diagram, we're going to have force of gravity going downwards, and then we're going to have force of tension of mass 1 going up, and then our sigma F statement in the y direction is going to be x, which is the mass of 1, and then the acceleration of y, which is equal to ft minus the force of gravity. And then after that, we're going to have 0.5 meters per second per squared times x equals ft minus m1g. After which, we're going to have ft equal to x times half minus or plus g. So starting off with the free body diagram of the third mass, we're going to have Fg3 going in the downwards direction, and then we're going to have Ft2 going up, and then for a sigma F statement in the y direction, we're going to have mass of the third block times A in the y direction equal to mass of the third block times G minus Ft2. And then substituting in values, we're going to have 2x for the mass and then 0.5 for the acceleration. And then we're going to have 2xg, which is just derived from the original mass of the third block. And then 2x times 0.5 obviously equals x, which is equal to 2xg minus ft2. And then we can just switch around the terms, and we're going to get ft2 equals 2xg minus x. Next, for the free body diagram of the second block that was laying on top of the table, we're going to have Fg2 going downwards, then we're going to have the normal force going up, and then to the right we're going to have the force of tension 2, and to the left we're going to have the force of static friction as well as the force of tension 1 from mass 1 on the left side. And this is all for mass 2. Next, for the sigma F statements of block 2, in the y direction, we're going to have m2 times a in the y direction, which is 0 because the block is not moving in the y direction up or down, which is equal to force normal minus the force of gravity on the block. And we're going to have force normal minus 2xg, and the 2x is, again, just given from the given of the weight of, or the mass of the block. And moving around, we can get Fn equals 2xg. Following that, we're going to have the sigma F in the x direction equal to m2 times its acceleration, which is equal to ft2 minus ft1 minus the force of friction, which is the same as mu k times Fn. And then using the given values, 2x and 0.5, which is equal to m2 times ax, which is equal to ft2 minus ft1 minus mu k times Fn, which we have substituted for, or 2xg, which we have substituted for Fn. And then reducing that, we can get x equal to ft2 minus ft1 minus mu k 2xg. After which, we're going to have x equal to 2xg minus x minus 1/2 x plus xg minus 2xg mu k. And mind you, these are all the values of force of tension 2 and force of tension 1 we got from the first sigma F statements. Next, all I've done is taken out all the x's from each of the terms, and we get x times 2g minus 1 minus half minus g minus 2g mu k. And then we're going to divide by x, which gives us 1 equals 2g times 1 minus mu k minus 1.5 minus g. And then what we're going to do is just bring it all to one side and isolate the mu k value, which is 1 plus 1.5 plus g over 2g, and that's going to be subtracted from 1, which is going to equal mu k. And if you plug in all your given values, or rather gravity, you're going to get mu k equal to 0.372, and we're going to round to 3/6, and that's how you get the final answer.